This is Unit 7, Circles, Lesson 7.1, Circle Parts. You want to have your new set of preview notes? That is your calendar for the next month all the way past Easter break. Here's your communication page. The next two pages are your reference pages. There's a blank page and filled out, another blank page and filled out. These must be memorized for our next test. Starting on today's lesson, 7.1, you should be watching this sometime on March the 6th and 7th prior to class on the 8th or the 11th. Make sure you make a note of where and the date and time you are watching this video, as well as get a parent-guardian sign-off. Let's do a quick recap of our previous lesson. We have 4 points here. Let's start by graphing. A is at -3, 3. So -3, +3. Every time you put a coordinate, I want both a letter and a coordinate. B is at 1, 5. So over 1, up 5. C is at 4, -1. So 4. -1, that's C. And D is at 1, -5. So 1, -5, that's D. Now you want to close it up. Okay, our goal here is to determine if, that's a key word, ABCD is a parallelogram. Now remember, the 5 qualities of a parallelogram are the OCD qualities. Let's fill the rest of those out. Opposite sides parallel. Opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, diagonals bisect. Now when we work in a coordinate plane, we're working with midpoint equation, the slope equation, and the distance equation. Now we need to match these up. If we wanted to show opposite sides are parallel, that's an issue of tilt, we would use the slope equation. If we want to know opposite sides are congruent, that's a length issue. We would use the distance equation. Opposite angles congruent, we really can't use any one of those, so we're not going to touch that. Consecutive angles, supplementary, we can't use midpoint, slope, or distance for that. Diagonals bisect, that means they go through each other's midpoint. So the goal mathematically is to use either slope, distance, or midpoint to test to see if it's a parallelogram. I'm going to go ahead and use slope this time. So remember, slope is y minus y over x minus x. That's rise minus run. So we're going to do this together. First, we're going to work these two sides and check for slope. And then we're going to do these two sides and check for slope. In fact, let's do the green first. We're going to do the green first. So we're going to go y minus y. So box your y's, 3, -5. Let's go like that, and we're going to subtract 3 minus -5. That, of course, is 8. Now circle your x's, subtract -3 minus 1, that's going to be -4. So the slope here is -2 on this side. Let's try this side over here. Box your y's, subtract we're going to get 5 minus negative 1 over, circle your x's, subtract 1 minus 4. This ends up being 6 over negative 3, which is negative 2. Okay, so far, the green sides are parallel. Let's check the blue sides. Y minus y. 3 minus 5 is negative 2. X minus x. Negative 3 minus 1 is negative 4. So I get positive 1 over 2 for our upper slope, A to B. Let's check our lower slope, y minus y. I'm going to have 5 minus negative 1. That's 6. And 1 minus 4. That's negative 3. Okay, that's negative 5 minus negative 1. Negative 5 minus negative 1, that's positive 1, that's going to be negative 4. And then 1 minus 4 is negative 3, so it's 4/3. Whoops! Take a look here. These slopes here, I'm going to circle them. That's 1/2, that's 4/3. They don't match. So although this is parallel, the blues are not. So technically what we have here is a trapezoid. It's not a parallelogram. We have a trapezoid. It's not a parallelogram. That's a review of our previous chapter. Let's move on to today's material, which is super easy. We're going to introduce ourselves to circles. And by the end of today's lesson, you're going to know all these terms. Many of them you already know. Obviously, circle. The word radius, diameter, check these off as I read them. Central angle, minor arc, major arc, semicircle, concentric, a chord, a secant, tangent, and the word measure. What I'd first like you to do is take a look here. You have all these words. I want you, to the best of your ability, to put any of these vocabulary words on the diagram. If you know anything about a circle, I'd like you to just take a minute or two and try to draw any of these. I'm going to give you about 30 seconds to try to figure out how to do any of these. Now a circle here, obviously this outer edge is the circle, so I'm just going to put it right here, that's the circle. Now put a letter smack dab in the middle here. I'm going to call that W. We name circles by their center point. So if I put W right there in the middle, I would call this circle W, or the symbol I would use would be a little dot inside a circle. That's the symbol for circle W. So when I say circle W, that implies W is automatically the center of the circle, which we have right here, center. So that would be the center of the circle. A radius connects center to the edge. That's a radius. Now a diameter is 2 radii, so it goes through the middle, but it goes from edge all the way to the other edge. But through the center, that's called a diameter. So just put this as the margin. One diameter always equals 2 radii. Because this is a radius, and technically that's a radius as well. A chord is any segment that has endpoints on the circle. So if I have an endpoint here and an endpoint here, and you connect, that is a chord. Tangent is a line that touches the circle from the outside. Touches the circle from the outside. So if I draw a line here just touching the circle, let's say we'll call that line M. We would say line M is a tangent. And where the tangent touches the circle, that would be called a point of tangency. So a tangent touches the circle at one point. Point of tangency is that point. Now a secant is a line that starts outside a circle Now a secant starts outside the circle and goes through the circle. So a secant, let me draw a couple of them. A secant can come from the outside and just go through the circle and stop on the far side. That would be a secant. Or it could start from the outside and just goes through the circle completely. It could be a segment, or it even could be a line. So these two orange lines represents different kinds of secants, segments or lines, as long as they go through the circle, starts from the outside and goes through the circle. The trick to a secant is a secant intersects the circle at 2 points. Let me show those 2 points in yellow. There's 1 point and 1 point of intersection, and 1 point and 1 point of intersection, and it starts from the outside. That's called a secant. Take a moment and make sure you have all that written down. This vocabulary is critical to the rest of the chapter. Okay, so on this page, you're going to test yourself here. And I'm going to do 2 of them, and then you're going to do the rest. And what we're going to do here is fill this out. So it says name a circle. And remember, we name circles by the point, so I would call this circle A. Then it says name a radius. Now radius goes from center to edge. So one radius would be AF, and that's a segment. You have to put the segment line there. I want you to find another radius and put it in, and then I'd like you to do the rest of these. You start working on that. I'm going to give you a minute to do that. Go. Okay, let's see how you did here. A diameter goes, and your other radius would of course be AH or HA, same thing. Your diameter would be all the way across, like so. So the diameter is going to be HF or FH, same thing. Your chord, there's a couple of them you can do. CD would be one. Another one would be DG or GD. A tangent, there's only one. Your tangent is right here, and you can name that line using any 2 points. So I would call it line BH, and it has to be a line because it goes all the way, or HJ, or even BJ. Your point of tangency is this 1 point H. You only have one secant. Secant goes through the circle all the way, so again it's a line, and so I would call that line BD with an arrows because it goes through. I could even call that line BC because it arrows going through. So there's your basic vocabulary. Make note of the ones you got right, and especially the ones you got wrong, and go back and restudy this. Now there's a vocabulary of position between circles, position between circles. Let's go over that. These 2 circles here, I'd like you to trace them. Then trace this one. These 2 circles are circles that intersect. They cross each other and they intersect. Intersect. Okay, circles intersect, and they intersect at 2 points. Now trace this one. That's a bad trace there. Let's try that again. Trace this one, outer one. Trace the inner. Here I have circles that intersect at 1 point. 1 point. They touch at 1 point. I'd like you to trace these 2. Circles that share a common center, the green and the blue here, those are called concentric. Concentric circles. Con means with, centric, center. It means with the same center, concentric circle. And the last one is, if the radii are congruent in 2 circles, then you have 2 congruent circles. If the radii are congruent, the circles themselves are congruent. So again, your vocabulary is circle intersection, concentric circles, and congruent circles. All right, now we have 4 more terms here, and after we have these terms, then we're going to start doing some math together. We need to understand the term minor arc, major arc, a semicircle, and a central angle. Minor arc, major arc, a semicircle, and a central angle. A minor arc, first I'm going to trace, then I'll give you the definition and then the symbol. So trace, definition, symbol. So trace with me, please. A minor arc would be from here to here. A minor arc is, I'm going to type this, it's very important. A minor arc is a part of circle's circumference, which is less than 180 degrees. Part of a circle's circumference less than 180 degrees. That's called a minor arc. A portion of the circle's circumference which is less than 180. The fact that is less than 180, that is what makes it a minor arc. We label minor arcs using 2 letters. So watch, I go B, C, 2 letters. Now put the little arcy symbol. That means the minor arc. If it's 2 letters, it's less than 180 degrees. That's a minor arc, part of a circle's circumference less than 180. Now a major arc is going this way. Start at B and sweep it all the way around. That's a major arc, what I just traced. You trace it. Start at B, sweep past D, and go to C. That's called a major arc. So major is like a minor. It's also part of a circle's circumference. But in this case, you can see it has to be greater than 180. Bigger than half a circle for it to be considered a major arc. So remember, a minor arc, we use 2 letters. BC, arc, that's a minor arc. For a major arc, we have to use 3 letters, must use 3 letters. Let me give you several names. We started at B, and we're going to go this way, so we could call this the major arc, that big red, BDC. That would be a major arc. But I could also go the other way back around, 1, 2, 3. I could also call that arc CDB and go this way. That names the same arc. So you have to use 3 letters for a major arc. In the one up here, BDC is that red major arc. Starting at C, DB, it also names the same major arc. Notice D's in the middle there both times. And we end with the end points B and C. So it's the same arc, it's just we went different directions. Semicircle, of course, means half a circle. So sweep over here and darken it. Semicircle is simply half of a circle, or an arc which equals 180 degrees exactly. That's a semicircle. Semi meaning half. So a semicircle, we use 3 letters. So you must use 3 letters. So I could call this semicircle EHG, or I could go the other way, GHE. That names a semicircle. A central angle Trace and sweep. B-A-C and sweep. Trace it again, please. B, start at B, go to A, go to C, and sweep. Do you see how A is the center of the circle? So we would call BAC a central angle. A central angle. That is an angle vertex on circle center. Think of it as a pie slice. That's a central angle. An angle whose vertex is on the center, or a pie slice. In this case, our central angle is going to be angle BAC. Okay, using all this vocabulary, we're going to do a couple problems together, and then you'll be done. So, things to remember. I'd like you to sweep this angle, and then sweep the angle, and then I'd like you to sweep the arc. Sweep the angle, sweep the arc. I'd like you to sing this after me. Measure of a central angle to its arc the same. Sing it again with me this time. Measure of a central angle to its arc the same. Which means this specifically. Let's say the measure of angle BAC is 60 degrees. So we write, underline central angle, and now let's give an example. The measure of angle BAC equals 60 degrees. That means that's a central angle, a pizza slice. Draw a little arrow. That means the degree measure of the arc BC. Underline arc. Now do this. Measure of arc BC with a little arc above it. The degree measure of this arc is also going to be 60 degrees. So that means measure of arc BC equals 60. So if the angle is 60, the central angle is 60, the degree measure of the arc is 60. Measure of a central angle to its arc the same. Next one is, if you have congruent angles. If you have congruent central angles, so sweep those, notice those are bow tie angles anyways. If you have congruent central angles, you have congruent arcs. Congruent central angles will give you congruent arcs. Last one's a real simple concept. If you have adjacent arcs, then you can add them. I'll give you an example right here. We're going to use different colors. For example, I could say that the measure of arc A to D. So we're going to do measure of arc A to D. So I have the measure of arc A to D and the measure of arc A to E. Notice I'm using two letters there. The reason is because they're both minor arcs, A to D plus the measure of the arc A to E. that will give me the measure of the arc, which is now a semicircle, obviously, because this is the central angle, so I have to use 3 letters here, gives me the measure of arc DAE. So little arcs add up to big arcs. That's all that says. Little arcs add to big arcs. Repeat after me. Little arcs add to a bigger arc. Say it. I don't care if you're in the library, you'll say this out loud. Little arcs add up to a bigger arc. Say it. Okay, we're going to do one problem together, one problem on your own, and then you'll be done. Underline with me. In the diagram below, EB is a diameter. AF, AD, and AC are all radii. The measure of angle FAB is 60, and BAC is 62. Find all possible arc and angle measures. Okay, let's start with something simple. EB is a diameter. Whenever you see that word diameter, I want you to write this word stretch. Stretch. When you see diameters, I want you to stretch them out. So first, here's E, trace to B. Okay, now what I want you to do is I'd like you to stretch it beyond the edges. Stretch that out. Diameter, stretch. That's a diameter. Just stretch it out. Now, whenever you do that, I'd like you to do one giant sweep. Diameters automatically divide circles into semicircles, 180, 180. So just get in the habit of stretching out diameters. AF, there's AF, AD, and AC are all radii. Next, FAB is 60, so we go F. AB is 60, which we have. Cross it out. BAC is 52, so BAC is 52. Trace and sweep. BAC, trace and sweep. Now from here we want to find everything possible. So I'm going to walk you through just this one. We learned that the central angle, so sweep this 60, is the same as the degree measure of the arc. So right here, I know the measure of arc FB is going to be 60 degrees. Because measure of a central angle to its arc the same. Say it again. Measure of a central angle to its arc the same. Which means if this is 52, that this arc here, the measure of BC, must also be 52 degrees. Now, we ask ourselves, what else can we find? Trace with me, please. Trace, that's 60. Now go from here to here, keep going. This is why we stretched out our diameter. Do you see it? Adds up to 180. So we can go 180 minus 60 will get us the light pink angle, which of course is now 120. If the arc is 120, that means this angle here is 120 degrees. Let's see what else we can notice. I see a 90 degrees here. And if that's 90, that means from here to here must also be 90 degrees. So we go like this. The measure of DC, the arc, must also be 90. I'm going to wait for you to catch up. Now we notice we only have one more angle here to get, but we have a diameter, and we know from here to here is 180. So we have so far 52 plus 90. So let's add that in the margin. 52 plus 90 is 142. 180 minus 142. Of course, is 38. That means this is 38, and that's 38. And now we have found every single arc and every single angle in this diagram. Alrighty, I'd like you to do page 13 on your own. I'm going to set the timer for 3 minutes. I want you to finger track read, and then I want you, after you finger track read, you filter, you draw, you label, you list any information, you cross stuff out as you do it, and you ask yourself, what can you do? I'm going to set the timer for 3 minutes. Start reading, go. All right, let's see how you did with this diagram. Okay, it says circle T. Well, step number 1, circle T means T is the center of the circle. So we're going to put T right there. Has diameters PQ and SR. So PQ and SR, 2 diameters. So here's PQ. And SR, and we want this R, PR, to be twice the size of our Q, so that we have to tilt it. So there's SR. Now we're going to double check. That means we want arc PR, so I'm going to trace it like so, is twice the length of R to Q, which I'll do in green. So we have, and we don't know the measures, but we do have an X and 2X relationship. We want to find all possible arcs and angle measures. Well, remember, see that word diameter? Remember I told you to stretch out diameter? So I'm going to stretch out PQ, and that should register in your brain when you stretch stuff out. Oh, that, of course, is 180 degrees. Now, this is a very easy problem. If you notice that 180, that means I can do this. The measure of PR plus the measure of RQ equals 180. Remember, we do things first. Things first. Always. You talk about things before you talk about numbers. And then we have P to R is 2X, plus R to Q is going to be 1X equals 180, and you solve here, and we get X, of course, is 60. That means R to Q is 60 degrees, and this is 120. Now you just start working it over. Measure of a central angle to its arc the same. So if this is 60 degrees, this right here, central angle, RTQ, is 60 degrees. Oh, and we have a vertical angle. Looky there. So that's also 60 degrees. Which means this arc on the other side, P to S, is also 60 degrees. Then we work this side, that's 120, which means this central angle, PTR, is also 120. Vertical angles, which means this is 120, which forces the minor arc, S to Q, to be 120. Now we have found all possible arcs or angles.